So 9.3 deals with solving rational equations algebraically. When you're asked to determine the roots of an equation, you're looking for the solutions. You're looking for the zeros. You're looking for the value or values of the variable that makes the equation true. So you're solving the variable, right? And this can be done algebraically. And because we have rational equations here, you're going to have at least one denominator. And so your first step will be to multiply each term by the common denominator. So our denominator here is x plus 2. So you're going to multiply all of the terms by x plus 2. And the right side, when you multiply that by x plus 2, it doesn't matter because 0 times anything still gives you 0. So we can show that we're multiplying it by x plus 2, but it'll stay 0. So you've got three terms on the left. Remember, terms are separated by pluses or minuses. All three terms are multiplied by the common denominator. And on the right side, 0 is also multiplied by the x plus 2. And the whole point of doing that is so for that middle term on the left, the x plus 2's cancel. This is the reason that we multiply by the x plus 2. So multiplying out what's left, we'll have x squared plus 2x. You're just left with plus 6 for that middle term. Minus 5x minus 10 equals 0. And because we have x squareds and x's, we're going to collect our like terms, and chances are we're going to have to factor. 2x take away 5x is minus 3x. 6 take away 10 is minus 4. And so now we factor, and that gives us two solutions. Our solutions will occur where each factor equals 0. So x will equal positive 4 and negative 1. And we always need to check to make sure that these answers work. Sometimes they don't. Sometimes you have extraneous roots. So we will check, starting with the original equation. So starting for x equals positive 4. You'll have 4 plus 6 over 4 minus 2, take away 5. 4 take away 2 is 2. 6 divided by 2 is 3. 4 plus 3 is 7. Oh, so that's a mistake. That should be x plus. So that'll be 6 over 6, which is 1. And that one works. 4 plus 1 is 5. Minus 5 is 0. So that one works. And now we'll check for x equal negative 1. We're going to have negative 1 plus 6 over negative 1 plus 2. Take away 5. Negative 1 plus 2 is 1. 6 divided by 1 is 6. So negative 1 plus 6 minus 5 also equals 0. So they both work. So next it says to graph the rational function and determine the x-intercepts of that graph. So we'll have x plus, now that next term is a rational expression, so we're going to have to use brackets to keep it together. The top is just 6 divided by, and we're going to have to use brackets again to keep the numerator together. So close the bracket on the denominator, close the bracket on the expression, minus 5, enter. I'll change my windows to their standard settings, zoom 6, and we're asked to find the x-intercepts, which are the zeros. So second function trace, number 2 is 0. If I want to find the 1 on the left, I'll set my left boundary at -2, my right boundary at 0, and we get x equals -1 as one of those x-intercepts. To find the second x-intercept, second function trace, number 2 for our 0. I'll put my left boundary at 3, my right boundary at 5, and it gives us x equals 4 as our second x-intercept, which matches the solutions or the roots to the equation. So the connection between the two is that they are the same. The roots of an equation equal the x-intercepts. They are the same. So when you're asked for the roots, you're asked for the x-intercepts. It's the zeros, it's also the solutions. They all mean the same thing. Now example 2 asks us to solve this one graphically and express your answers to the nearest hundredth, which means that the answers are going to probably be irrational. So they have to be rounded. The other thing that's different about this one is you've got two different equations. You're going to have to put two different expressions in here and then find the points of intersection. On the previous one, we had one equation equal to 0, so we found the x-intercepts. This one, we have two different equations, one on the left, one on the right. So y1 will be the left side, and it's a rational expression, so I'm going to have to use brackets to keep numerator and denominator together. Whoops, forgot the x there. So x squared minus 3x minus 7, all in brackets, divided by, all in brackets, 3 minus 2x. Now that has to equal x minus 1. So again, because we have two different equations, we're going to look for points of intersection. And there are 2 points of intersection. Second function trace, number 5 for intersect, enter, enter, enter. So my first x value is 0.43 negative. And it's kind of hard to see there, but if I quit out of this and I go x enter, it'll take the last x value, just makes it easier to see, negative 0.43. And it's an approximation because we rounded it. Our second one, second function trace, number 5 for intersect, enter, enter. I'll put my guess at positive 3, and it's actually 3.997 it looks like, just to make sure, 3.097. So if I round it to 2 decimal places, it'll be approximately 3.10. And we can get those same 2 answers by doing this algebraically. And like we did on the other side, on the first example above, we can multiply both sides by the common denominator. There's only one denominator here, 3 minus 2x. So that's what we'll multiply both sides by. And the whole point of doing that is so on the left side, the 3 minus 2x's cancel. And we've now gotten rid of denominators. We multiply out what's left on the right, and then solve the resulting equation. So this will be negative 2x squared. It'll be 3x plus 2x, which is positive 5x minus 3. So we've got x squareds and x's. We need to make it equal to 0 and probably need to factor. So adding 2x squared to both sides gives us with positive 3x squared on the left. Subtracting 5x from both sides gives us minus 8x. Adding 3 gives us minus 4. And this is not factorable. But we can still solve it by using the quadratic formula. And it's on your formula sheet. So you don't have to memorize it. So the b value is negative 8, therefore negative b will be positive 8, plus and minus the root of b, which again is negative 8 all squared, minus 4 times a, which is 3, times c, which is negative 4, all over 2 times a, or 2 times 3. We can use our calculator to get us the value of the discriminant. That's, remember, the name for what's under the radical. Negative 8 all squared minus 4 times 3 times negative 4 gives us positive 112 into the radical. And that can certainly be reduced. 112 is divisible by 4. I think 28. Yeah, which is also divisible by 4, which means the original number 112 could also be divided by 16. Yeah, root 16, root 7. And we would do this just so we can simplify the answer. Because the root of 16 is 4. And now all three terms are divisible by 2. And that gives us our simplified answer as exact values. So to check it against the 2 decimals that we found above, again, we can use our calculator. Keeping the numerator together in brackets, we'll do 4 plus 2 root 7 all over 3. So there's that 3.1 number that we got on our calculator. And then for minus 2 root 7, there's a negative 0.43 that we got in our graph. And the fact that the graphical solution showed that there were 2 answers means that both answers are valid. If one of them wasn't, the graph would tell us that. The graph would only show 1 if 1 wasn't. Okay? So this one can be done graphically. Again, when it says to the nearest hundredth, tells us probably that the answers are irrational. So when we solve them algebraically or verify algebraically, we might have to use the quadratic formula. But we'll see. Also, for this one, we have 2 different denominators, positive 2 and 4x plus 10. Now, there might be some in there, right there. If you factor that denominator, the 4x plus 10, it'll help us when we get to part B to find our lowest common denominator. But the first part is doing it graphically. Again, we have 2 different sides, left and right. So our left side will go into y1. We've got 2 minus, second term's a rational expression, which is 3x over 2. So there's equation 1, the left side. The right side, we're going to have to use brackets to keep the numerator and denominator together because they are polynomials, trinomial and a binomial. So 1 plus 4 minus x squared, 1 plus 4x. And that's all divided by, in brackets, 4x plus 10. So graph, and there are 2 points of intersection, it looks like. The first one, put my guess at -5. It's at -3.338, it looks like. Yeah, so -3.34. Our second one, I'll put my guess at +1, and it looks like 1.14. And those are approximations because those numbers appear to be irrational, so they need to be rounded. To get the answers algebraically, we need to multiply all 3 terms by the common denominator, which will be 2 bracket 2x plus 5. So all the terms, the 2 on the left, the 1 on the right, are multiplied by the common denominator so that the denominators all cancel. And that is the whole reason why we use that step. So 2 times 2 is 4 times 2x plus 5. Then I have minus 3x times 2x is minus 6x squared. Minus 3x times 5 is minus 15x. And that will equal, I'm left with 1 plus 4x minus x squared. So I've got x squareds and x's. Chances are we're going to have to get a quadratic equal to 0. I'll add 6x squared to both sides, which will give us positive 5x squared. On the left side, I have 8x, take away 15x, which is minus 7x. I'll add that to both sides, add it to both sides, and get positive 11x. I'll subtract 20 from both sides and get minus 19. And again, this is not factorable. So our solutions will come from using the quadratic formula. Negative b plus or minus the root of b squared minus 4 times a times c, which is negative 19, all over 2 times a. So we'll use the calculator again to get the value of the discriminant. 11 squared minus 4 times 5 times negative 19 gives us 501. And because we just want to verify our irrational numbers, we don't really have to try and simplify that. I'm not sure that 501 can be reduced, so we'll just use the calculator to get our answers. So negative 11 plus the root of 501 in brackets, all divided by 10. So there's our 1.14 answer. and then negative 11 minus the root of 501 all over 10. There's our negative 3.34 answer. So it verifies. And as we said, you always need to check to determine whether or not one or more of your answers that you find are extraneous. Right? And the graphical solution will do that. So you really have two choices when you're going to check or verify. You can check algebraically, which we did earlier today, but the other option is to check graphically. So we're first asked to solve this algebraically. So the denominator can be factored, and it just helps you find the least common denominator. In this case, your least common denominator will be 2 bracket 2x plus 5. When we factored the denominator here, we got a factor of 2x plus 5, which is one of my denominators. So I'm going to multiply all the terms by 2 bracket 2x plus 5. And the whole point of doing that is so that we get rid of all the denominators. If we multiply out what's left, you'll have 2 times x plus 2x times 2 is 4x times 2x gives us 8x squared, and 4x times 5 is positive 20x. Make it equal to 0. We subtract the 8x from both sides and subtract the 15 from both sides. Sorry, there was no number on the left. They're both x's, so that'll become minus 15. And checking one more time, 22x take away 8x is actually 14x. So 8x squared plus 14x minus 15 equals 0. And this one is actually factorable. Front terms multiply to get 8x squared. The last terms multiply to get negative 15. So 5 and 3 are the numbers that'll work. And if it's a positive 5 there and a minus 3 with the 4x, the outer products are negative 8x, the inner plus 20x. That gives us a middle term. Or negative 6x, excuse me, plus 20x is my positive 14x. And your solutions will come where each factor equals 0. So here we will subtract 5 and divide by 2. So it's where 4x equals 3 and x equals 3/4. Okay. Now, we want to check them. And in this case, we will check them graphically. y1 will be the left side, which I'm going to have to use some brackets here to keep the rational expression together and also to keep the denominator together. The right side will be equation 2. 8x plus 15 on top divided by 4x plus 10 on the bottom. So I use the original denominator, not the factored one. Just they have the same value. It's just easier to use the original, putting it in the calculator. So when we graph it, it looks like there might be two solutions, but let's check. Second function trace, number 5 for intersect, enter, enter, enter. So 0.75 or 3/4 definitely is a solution. Let's check negative 5 halves. Second function trace, number 5 for intersect, enter, enter. Put my guess at negative 2.5, which is what negative 5 halves is, and it goes back to the 0.75. So that means that negative 5 halves is an extraneous root. So you have to do something to show that. Ideally, to be safe, you could say x equals negative 5 halves is extraneous. And box the correct answer. So the graphical solution has its merits for sure, right? It's usually a little bit easier as long as you type everything in correctly. It also tells you whether you have extraneous roots or not. Where it cannot be used if you want to state the answers as exact values. So that's where you have to come up with a quadratic and then use the quadratic formula. On the previous one, those would be the exact values of the solutions. But if you're rounding and it doesn't say solve algebraically, you could use the graphing calculator. Okay? So for this next one, if you take out a common factor of 2 here, you'll get x minus 3, which is not the same as 3 minus x. It's the opposite. So if you take out a common factor of negative 2, then you'll get positive 3 minus x. You'll get negative x plus 3, which is the same as 3 minus x. So this helps us get our common denominator to solve it algebraically. We're going to multiply all three terms by our common denominator, which will be negative 2 bracket 3 minus x. So the x plus 3 is multiplied by negative 2 and 3 minus x, which is the same as 2x minus 3, or 2x minus 6, I should say, so they will cancel. And again, the whole reason we do that is so that we can cancel out the denominators. And then we solve with what is left. So negative 4x times 3 is negative 12x, and negative 4x times negative x is positive 4x squared. Negative x times negative 2 is positive 2x. We're going to make this equal to 0. I bring everything from the left side over to the right. On the right, you have negative 12x plus 2x, which is negative 10x. When you subtract the 1x from both sides, you're going to get negative 11x over there, and then the 3 will come over as well. So there's the quadratic that we need to solve. It's not factorable. Or is it? Yeah, it is actually. So negative 3 there and plus 1 there. The front terms multiply to get 4x squared. The outer product's negative 12x, the inner plus 1x gives us our negative 11x, and we have the minus 3 on the end. So our solutions will come when each factor equals 0. So we'll get negative 1/4 and positive 3. And we'll use our graphing calculator to see if any of these are extraneous. So for the equation on the left, which is what we put in y1, we're going to have to use some brackets to keep the numerator and denominator together. And same thing with that second term for equation number 2. It'll be x on top divided by, in brackets, 3 minus x. Close the bracket on the denominator, close the bracket on the expression. Quick check, x plus 3 over 2x minus 6 is right. 2x take away, x over 3 minus x looks good. So second function trace, number 5 for intersect, enter, enter. If we check negative 0.25, which is our negative 1/4, that works. That is a solution. Checking the second one, which is positive 3, it goes back to the negative 1/4. So positive 3 doesn't work. We can cross it out and we can state x equals 3 is an extraneous root. The only one that works is x equals negative 1/4. So if we compare the solutions found using each method, the algebraic shows 2 solutions. Which need to be checked. To determine that x equals 3 is extraneous. The graphical solution shows that there is only one real root. Okay? On page 465, questions 2 through 4. Should work on those. Yes. In a minute. So that concludes this chapter, which means next class we're going to be starting chapter 10, and then you guys will also have a quiz on chapter 9. Next class. Okay? What's so funny? Okay, you can go ahead to the washroom, Sant.